Right. Welcome, everybody. I'm going to share my desktop here, make sure I'm sharing the right thing. All right. And now you can see everything that's on my desktop, which is just a joy. Anyway, so I'm going to start with a little bit of some presentation stuff, but don't worry, this won't be death by PowerPoint. And of course, I didn't go back to the beginning. There we go. So this actually came up at a really good time because I'm in the midst of getting the next version of the Helm chart ready for release, which will probably happen early next week. As you may or may not know, we released 2.4.5 of Logstream last night or yesterday. The Helm charts, I tend to kind of follow that pattern. I usually try and be within a week, but sometimes it takes a little longer. But the thing that's nice about this time is we have a ton of new stuff in the upcoming one. So it actually is great that I get to demo it. I'm actually really excited about this stuff. So the theme of what I'm calling imminent Helm chart improvements is really just about configurability. When we first put out the initial Helm chart, it was really about getting the things that we could easily configure that were, I guess, kind of easy to manage in there. So things like license, setting up groups, setting up the URL string for the worker groups to connect to the master, that kind of thing. But that's not very flexible. So what we wanted to add in this go around is a lot of flexibility to allow people to come up with ways of configuring things or come up with ways of doing things differently that we didn't think of. So with that, the master chart, we're adding support for ingress. If you're not familiar with ingresses, they're basically layer 7 load balancers. They kind of they sit in front of services in the Kubernetes space, and a lot of companies are starting to use them as, or not starting to, but are using them as kind of security barriers, a kind of an endpoint that they can manage directly. And then everything else in here is arbitrary in front of it, and that's really just because the idea is that you can go ahead and create Kubernetes objects otherwise outside of the chart, and you can expose them into the chart. So you can do things like arbitrary init containers. And an init container is a container that runs before the actual container of a pod. So, in something like the master where we have persistent storage, you might run an init container to do something to that storage before the Logstream container comes up. So you might want to do things like changing permissions or seeding files or that kind of thing. So that's what an init container can do. Secrets, Kubernetes has a secret store where you can use to store passwords, passcodes, API keys, etc. Those can be, in Kubernetes, those can be exposed as mount points in a given pod or as environment variables or a variety of other ways. That's where this arbitrary secret mounts comes up. So we're now giving you the ability, if you have a secret in your environment, you can now expose that within the pod. Same thing with config maps. A config map and a secret are very similar, but a config map is not really a secure storage endpoint. It's really there to store configuration information that's specific to whatever workload is actually running there. And I'm going to show you that because that's kind of a key piece of what I'm going to demo. Also, the ability to do arbitrary volume mounts. This is going to be probably more important on the worker group than it is on the master, but that's the ability to have a volume that is not necessarily a part of the Helm chart that's available to each one of the containers. And when I get to the worker group, I'll explain why that might be more relevant there. Alternate security context, this is the ability to run as. We already can do this in the product when you deploy it on, on bare metal, if you will. Doing it in Kubernetes is a little bit different. But now we support it. So you could actually, once this is in place, the entire, all of the operations in the container will run as that user. So there's that. And then mfroms. This is a way to expose Kubernetes metadata to the pods. So you can do things like pulling pod name, node name, all sorts of things, and pull them into the pod. On the worker group side, it's a very similar set of things with a couple exceptions. So consistent naming is one of them. If you've deployed the charts, you notice that in master you determine groups, and in the worker group side you determine tags. That's now been harmonized, so they're all group. So you create a group in the master, and then you point the logstream worker group at that group instead of a tag. The old nomenclature is still supported as a backwards compatibility mode, but it just makes it a little more sensible. Also a new option for runtime, and that is running as a daemon set. So by default, we run as a deployment, which just basically says, spin up a couple pods on the cluster. A daemon set, and then we use a horizontal pod autoscaler to autoscale that. And a daemon set, you run one instance of the pod on every node in the cluster. So this is great. This is really helpful for gathering data about the cluster itself. And you'll see more with that use case out of us pretty soon now. I'm working on a number of things. Then all the arbitrary things are there. And going back to the arbitrary volume mount, one of the things we've been asked for, and it still makes me nervous, is the ability to use persistent storage for persistent queuing in a worker group. Now, where this has been a challenge is persistent storage in Kubernetes can be pretty problematic. And depending on what kind of storage you use, you may not be able to mount a volume on more than one pod at a time. So if you do things wrong in this case, it can actually really, really hurt you. So there's going to be a lot of disclaimers about, try this at your own risk, but it does work. I've actually tested it. The other two things the other thing that is separate on the worker group is arbitrary role rules. In the later versions of the Helm charts, the worker group chart, we added RBAC setup. RBAC setup is within Kubernetes. It's effectively the ability to get at the Kubernetes API. Now we use this internally for doing collection against the API for like pod information and that kind of thing. We set one rule in there to start with, but there wasn't really any flexibility for more. So arbitrary role rules let you add to that. So if you want to be able to add multiple API groups or multiple types of permissions, you now can, or you'll be able to. You now can if you're on my laptop, but shortly you'll be able to do it if you're pulling from the main repo. Now this is, sure, all these things are great, but what do they really get me, right? Some of the things that are hugely beneficial internally, and I've talked to a couple of customers who are very interested in this, is being able to preload configuration. All of your log stream configuration ends up in files. So we can use the config map or even the volumes as ways to seed that configuration. We're going to be, once this Helm chart comes out, we're going to be revamping the demo environment, the demo setup a bit to make it simpler, because right now we have to do custom builds. But with this capability, we can actually inject all that data through these configs, through volumes, through config maps, through secrets. So it should simplify the way things are working. Exposing Kubernetes metadata to worker jobs. This is great for, I've got an example where I've been playing with different ways to get Kubernetes log and metric data into Logstream. One of those is actually using the Splunk Universal Forwarder. And I use this exposing K8s metadata to enrich that data coming in with the pod name that the log is coming from, the node name, the cluster name. That's all in the Kubernetes API, and we can easily expose that using the downward API, which is what the mfrom gives us, the mfrom capability gives us. But we also get a lot more ability, or a lot more capability, by enabling more access to the actual Kubernetes API. So both of those things are now kind of in play, and it should. I'm actually using this kind of setup in our corporate log stream to do pulls from the Kubernetes API to be able to do correlation between containers and the load balancer endpoints and incoming IPs and that kind of thing. So lots of options there. And then the one that's got 4 asterisks next to it, and that's persistent queues on persistent storage. I'll just repeat what I said earlier. Persistent storage can be problematic, so you need to be very careful with it. So your mileage may vary, but this is definitely something that can be done with these new capabilities. And then finally, ingress is a security control point. This is something we've heard from a few customers that they're trying to use this in their Kubernetes environment as a way to do kind of a choke point for security on things that are going through Kubernetes. We're going to use an ingress in this demo, so you'll see it in action. It is, right now we're only going to support it on the master chart. I haven't seen a good reason to support it on the worker groups because they're a little different as far as how they deal with different ports, how they deal with ports and services. So, but if you guys as customers or anybody who's out there, if you have a use case for it, please let me know. I'm happy to implement it. I just don't want to implement stuff that is not going to be used. So, or that's going to cause more problems. That's always a challenge, right? So just to give you an idea of what the demo environment looks like, the 2 things at the top, I'm going to be deploying a logstream master Helm chart with the configuration for a S3 data collector. And I'm going to be deploying a logstream worker group that's set up for 2 nodes or 2 worker nodes, but auto scaling up to 8. All of this is running right now on an K8s cluster. Almost everything you're going to see here should absolutely work on any Kubernetes environment. The differences are going to be in things like annotations, which I'll talk about when we go through values. Annotations tend to be more implementation specific versus Kubernetes overall. So, but the way we're set up in this environment is we have 3 auto scaling groups of worker nodes. Each one is availability zone aware. This is really important with persistent storage. I know I keep harping on the persistent storage can be problematic. One of the big problems I've run into, and we've seen this happen, I think now twice with customers, is when they deploy their worker groups, or sorry, their Kubernetes node groups, too many different names for things. They deploy it across all the availability zones. So what happens is you have a cluster autoscaler that says, okay, I have all these availability zones to work with. I'm just going to spin things up at random. So if I have a minimum node count of 2, I spin up in 2 of the 3 availability zones. Maybe I scale, I add, and the next one comes up in that 3rd availability zone. If I have something on one of those systems that has persistent storage using EBS, Elastic Block Store, it is availability zone aware or specific. So if that Kubernetes node dies and has to be restarted, right, and its workload has to be rescheduled, the cluster won't know that I can't put that on the other 2 nodes until it tries. So you'll end up with a lot of errors, and it won't necessarily scale to bring in that 3rd availability zone to make it work. So the way we've addressed that is we now have node groups that are set up for each availability zone. This makes it a lot more consistent. It makes it a lot more resilient. And we haven't really seen that problem internally anymore. So with that, just a little bit more info here. So we just added a version-based roadmap. Now it's pretty light. It's very much focused on this 2.4.5 instance right now, or 2.4.5 version right now. There's some stuff coming up for our next big release, which is 3.0. I have some stuff in there, but this is really community driven. So if there's a feature or something lacking that you would like to see, you have lots of options for getting it into the roadmap. One is just hit me with an @ in the Kubernetes channel in the community, or add an issue to the GitHub repo. If you know what you want to do and you know how to do it, please feel free to submit a PR. We love having other people submit this stuff. It helps give us a more broad perspective on what should be implemented and how it's implemented. So with that, we'll jump out of the slideware and move to reality. And you know what? I'm going to close this. You guys don't need to see the calendar. So I have in Kubernetes, I tend to use Lens, which is a Kubernetes, for lack of a better way of saying it, a IDE. I find it to be really, really useful. If you don't know the tool, I would recommend pulling it down and setting it up. Super useful for doing this kind of thing. So right now, I've tuned it down to just using the namespace that I'm going to deploy in, so you don't see any workloads. We have 4 nodes running right now in here, and no pods in that namespace. And we also have no services. We have no ingresses. We have an old ingress that's still sitting there. Anyway, let me kill that. Okay, so if I go back to pods here, obviously I don't see any containers in here in case, but one thing I want to show before we fire this off is the whole config map idea. So a config map is really just a way to store configuration information. One of the things I really like about it is you can do it from an entire directory. So I have a directory in here that all it's got is a jobs.yaml file. And the jobs.yaml file really is just the YAML file that configures a collector in this case. I'm going to put that now as a file. I can't really inject that easily into Kubernetes. But if I use things like the extra volume mounts or the extra config map mount capability, I can do so. So we're going to go ahead and create a config map from that directory in the namespace. So just to show, kubectl here is creating a config map called job-config. It's doing it from a file, but I actually gave it a directory. So that means it's going to read every file in there. And I'm doing it into this namespace logstream.ht. For those who are not super familiar with Kubernetes, a namespace is a way of doing a modicum of isolation within a Kubernetes cluster. It doesn't put in things like firewall rules, but it does kind of isolate workloads from one another. It doesn't mean you can't get around it. It just means you have to try to get around it as opposed to running everything in a single namespace. I tend to be really liberal about using namespaces. I create and use a lot of them. So that's just my philosophy. Everybody's mileage will vary. Now, if we go back to Lens and I go to look at config maps, you'll see that I now have this job config. And if I look at the data, you'll see there's a file named jobs.yaml, and there's the same content we saw. I could modify that in place or whatever, but that is my configuration file. Now, this is, I'm balancing between time here because some of these things kick off immediately, but take some time to actually come to fruition. So I'm going to start by doing the Helm install on the master. This command basically is telling Helm to install a release named lsms. That's just what I've named it, using a values file, which I'm going to show you in a second, called mastervalues.yaml. I'm also using the debug option, and I'm doing this locally as opposed to from the chart repository. But debug actually will print out all the manifests. So this is if you are ever having a hard time troubleshooting a Helm install of any kind, you can use the --debug to show you what manifests it's generating. And I find that really helpful because then I can go figure out, okay, why is this breaking? So a good thing to know. We're deploying it into the logstream.ht namespace. And this last one it says logstream master, but it's really the directory logstream master from where I'm in. If I was doing this from a remote repository, it would probably say Cribl /logstream master because that's how I configure my remote repository. But nonetheless, I'm doing this locally at the moment. So I run this, and you'll see in just a second, you'll see all of the resources scroll by. So you can see that's the manifest that gets sent to Kubernetes to set all this stuff up. Now, while that's building, now the reason I'm going to jump to something else is the ingress. Anytime with AWS that you spin up a load balancer, it takes a little while to show up in DNS. So the ingress is here, it's being created, there's a host name. I probably can't get to it yet. So we're going to take a quick look at the values file. This is the master values file, and you're going to see a bunch of stuff in here that's just for my testing, but it's all kind of pieces of the new chart. You can see I commented out my security context. I was running as user 1020 with a group of 30 before I turned it off for this. I've got an environment variable that I'll come back to because it's actually really important, but I can set arbitrary environment variables just like this. I've got a few end value froms. So this is, again, going back to what Kubernetes calls the downward API. And it's really just taking metadata that's in the pod definition and passing it into the container. So I've got an environment variable named pod name that is pulling from the metadata.name field in the metadata. I've got one called node name that's pulling from the node name field in the spec definition. So this gives me the name of the pod that this container is running in, and it gives me the name of the node that it's running on. There are all sorts of other values that are available there, but it's just a couple. I've got a couple extra volume mount points. I have a claim that I built. Sorry, I make sure that I'm covering the terminology that I'm using. A claim in Kubernetes, a persistent volume is a combination of an actual persistent volume, a claim for that volume, which kind of defines, in a dynamic environment, kind of defines the size and the provisioning aspects of it. But it also, that claim is used by the mount point to be able to pull it in. So what you see here in the second one is that I have a volume created. I have a claim created in this namespace called SWL test volume. And I'm telling it to mount it at var temp SWL test volume. You'll see a bunch of SWL. It's my initials. It's how I kind of keep track of what I put in for my own edification before I start checking things into Git. Extra secret mounts. I've got a secret in here that I'm mounting the same way. In the container, it'll show up as var temp swill test secret. But the important one is this job config. So we created this mount point, or sorry, we created this config map in the previous step. You saw me type the kubectl create config map from the file. That's what this is. And this, in this case, I'm telling Helm to mount the config map that's named job config at var temp job config. Now there's one file in there. If there were multiple files in there, they would all show up in this directory. Couple other things before we go back to the environment. Extra init containers. I have a very simple one in here that's not really doing anything other than just echoing that it happened, so that I can see that an init container gets fired up. Like I mentioned before, you can have things like, I want to mount the volumes that are going to be mounted on the main container, and I want to manipulate them. That's a great use for an init container. And then I have all the config that was already in here, right? So this is the stuff that was in the Helm chart to start with. SE name is storage class if you're doing persistent. If you're not using the default persistent storage class, you would specify it here. Cribl home, just the directory path. Reject self-signed certs. That's the it's just a way of turning off the certificate checking. In our environments, I turn that to 0 simply because I tend to use self-signed certs when I build things internally. Health port token. The token is the authentication token for the distributed environment. So we set that on the master. We also use it on the worker group. I have a license baked in here, and I'm not blurring it out because you're only seeing the first N characters, and there's a whole lot more. So unless you can figure out how to interpolate all the rest of those characters, I think we're okay. We set an admin password. I'm setting it to K8s demo. And then I define a couple groups. The next part, this is actually what this is like the default setup, where external type is a load balancer, internal type is a cluster IP. Services in Kubernetes are of 3 different varieties. They can be a cluster IP, which is internal to the cluster. So that would be for services that need to be used by other containers within the cluster. There's node port, which basically just exposes an arbitrary port on the outside of one of the nodes to make the service available. I say arbitrary, but it's well defined. So when the cluster first sets up, it'll define what that arbitrary relationship is. And then every time that service is exposed, it'll be on that same quote unquote arbitrary port. In our case, because I'm running everything in a Kubernetes cluster, I'm setting the internal type to cluster IP, because the internal service is for access from the worker groups to the master. And the external one is for UI, for your going into the UI. So I have them kind of separated that way. And then this final little bit that I just frantically scrolled past is the ingress. This is the new capability. So these two are the things that are Kubernetes specific. And then annotations are where we configure the actual ingress. And annotations are going to be different based on what implementation of Kubernetes you're running. So in our case, we're on EKS. I've installed the load balancing module for EKS. And so therefore I'm setting the ingress class to ALB, which maps out to a Amazon Elastic Load Balancer of the application load balancer type, which is the layer 7 load balancer approach. And then I have a couple things to configure it. There's a whole slew of annotations you can put in here. I just have the simple ones. I'm listening on port 80 as HTTP. You can also do, you can put in a certificate and do HTTPS. It's just a little hard to do because it's a little hard to do in a demo because I have to go do things with Route 53 to make it all point at each other. So I didn't do it for this demo, but it's actually pretty easy to do. And then we set the scheme. This scheme, in this case, equates to what AWS has set for their load balancers. They have the internal facing and the internet facing scheme. We're going to use the internet facing in this case. So that's our, going back to env. So this is the important part. We saw that we mapped, or we mounted the config map. Now you'll notice that I didn't mount it in the opt Cribl tree. And that's because mounted config maps, mounted secrets are all by default read-only. And in fact, it's generally not recommended that you make them read-write. So we don't want to mount that directly in a configuration volume that is going to get, it's going to get changed. So instead, what we're going to do is we're actually going to copy that file in just the first time. Because if you think about it, I deploy this master, I seed it with configuration, but then I'm going to go into the UI and I'm probably going to change some things. So in this case, I'm setting a tag file. I'm expecting a file called jobs imported to be there. If it's not there, then I know this hasn't run before. Whoops. If I scroll over, so it's looking for it. If the file is not there, then it's going to go ahead and make the directory tree if it doesn't exist, and then copy that jobs.yaml file over to the directory tree in the appropriate place. And then it's going to touch that file that I first tested for. So now the next time it runs, so it'll run the first time, it'll copy that file over. And I should talk a little bit about the naming of these environment variables. It'll copy that file over, and then it'll touch this test file so that the next time it runs, it'll see, hey, that the test file is there. I'm not going to do this. Now this Cribl before start, and there's also an after start option. This is a feature of our container. So our entry point script in the container has some logic in it that looks for environment variables named Cribl before start underbar, or Cribl underbar before underbar start underbar command underbar number from 1 to 30 sequentially. That's really important. Or replace before with after, and it'll execute the before ones before it starts logstream. So if I'm inserting a config file, I definitely want that to happen before logstream. If I'm running, say, a script that I have that goes in and does commits and deploys on everything, I would do that in the after because I need because it's looking for the Cribl command line. I said sequentiality is important, and that's because the entry point stops when it runs into a gap. So this is where it's going to get a little complicated. I'm still trying to figure out how to make this simpler for people, and would love ideas if anybody has them. But if I look at the actual running container in here, if I go to pods, and I scroll down to find the actual container definition, you'll see that all the environment variables are there, are showing up here. So I know that just because I did the chart, I know that if I specify licenses, a license or group, or really any config, if I specify licenses, I know I'm going to take up at least one before start command. If I specify groups, then I take up a second one. So because of that, I know that the next one I have available is 3. This is where I think it's going to get a little complicated, and I'm looking for ways to improve it so that you don't have to be so aware of what's going on in the environment. But nonetheless, so you see this before start 3 is the command I just went over. So what'll happen is when this comes up, it runs before start command 1, then it runs before start command 2, and then before start command 3, and copies that file in there. Now, let's go over to that ingress. Should be available by now. I'm going to copy this host name. Now, as I mentioned, you can do things in Route 53 to make this whatever host name you want, and you can use the certs to make it SSL based. So I'm going to go here. Oops, I'm not going to the fantasy football page, and I'm just going to put that in, and boom, now I have access to that log stream instance. I'll go in, I'll type in admin, and as I mentioned, I put in K8s demo as my password. Because I'm running HTTP, that little insecure pop-up came up, and I just got rid of it. I click login, I'm in, and because I have one password set to always prompt me, it shows up. One thing to remember is we don't automatically commit and deploy on first setup. So we're only going to be using the group 1. So I'm only going to commit and deploy that one. We could do all of them, but I'm going to go ahead and commit that and deploy it. Now you'll notice I have no workers here, and that's because I haven't deployed the worker group Helm. So let's go back to that. We'll walk through that install. Again, telling Helm to install with a release that I've named LSWG1. When I'm doing testing like this, I like cryptic names because I can make them really small and easy to type. I'm doing the debug. I'm putting it into the logstream HT namespace, and I'm giving it a values file as well, a different values file, and I'll show you that in a second. And then I'm pulling from the logstream worker group directory in this case. So you see that happen. It generates all of the resources or all of the Kubernetes manifests. And if I go back into my Lens environment and I look at pods, I've got one coming up, and this is important. So this is, I guess, useful. By default, our deployment only spins up one replica, but our horizontal pod autoscaler is set to a minimum of 2. So that's why one came up first, and then the other one came up afterwards. If I had set the deployment to 2, 2 would have come up and you never would have seen the other one go. Now, what I really want to show you is the ability for us to kind of auto scale on this. So let's do this down. So you see that we have 2 worker groups, and I'm going to fire off. Sorry about that. Accidentally moving things around when I don't mean to. I'm going to go to that group. Now you see we have 2 workers, right? So those have connected to the master and gotten their config. I'm going to go to my collector, and this is the one that this is where that job.yaml shows up. And just so you guys know, I'm running this in EKS with a cluster role that allows assumption of roles in other accounts. So you'll see authentication, I have nothing specified, but that's because I have an assume rule set. And I'm just pulling from one of our S3 buckets. I'm going to go ahead and do a full run on this. And I'm going to take, say, the last 5 days worth of data. And I picked our load balancer data because we get a lot of it. So if I start this, we can go back to the job itself. And we can see that it's doing its discovery. It's come up with a number of tasks it's going to have to create, and it's going to start chunking through those. Right now, you see we have 2 worker groups still, or 2 workers, sorry, 2 pods running. So for the moment, I'm going to show you the values file for that while we wait for it to kind of scale up on its own. We'll notice this as I'm walking through it. You'll see additional containers pop up here. So in the worker group values file, I have the same stuff I always have, except tag is now changed to group. I've set the same token. I've told it what service to connect to. I've also set up auto scaling. Now I've set up auto scaling to be really aggressive. So because I want to actually be able to show it. You see, we've already scaled. We've already added 1 instance in the scale. So I set my target CPU utilization to 40 because I know I'm going to exceed that. And we should see as this starts kicking in, you should see more. When I've done it, it's gotten to the 8 replicas fairly frequently, but it's mileage varies depending on when you run it. I've got an arbitrary environment variable set here. I've got resource limits. This is another thing I did, was tune them down. Yeah, you see we're scaling more. I've tuned them down so that we do hit those limits faster. But you can set, the defaults are about, I think, double this if I remember right. You can set whatever you want in those. I have the same kind of stuff I had in the master. I have NVIDIA value from, I have the volume mounts. In this case, I have an EFS volume. And this is going back to the idea of being able to use this for persistent queuing, persistent storage, persistent squared, I think I'm gonna start calling it. I'm using EFS because it is a shared storage mechanism. So more than one pod can connect to the same volume at the same time. And I'm using the subpath with the pod names so that in that EFS volume, you see directories for each pod, and then you'll see its queue underneath that. So it's very important to have shared storage as a mechanism for that if you're going to do it. Otherwise, you'll end up with contention issues. We have a load balancer configured. I also have a config map here, just to test one that I set up. And then I have the service definition, which is a load balancer type. And I'm setting, again, annotations to actually configure that load balancer. In this case, I'm configuring that load balancer to send logs to an S3 bucket at an interval of 5 minutes. And I can, it's just, there's a whole slew of annotations you can use for any of the load balancer types, services or ingress. And that's the config. So now as we see, we've bursted up to basically the max. I have it set for 8, and you'll see there's a little error. And this is the fact that it's kind of used up the resources I have available. It's saying I don't have a, well, it's saying one node is not ready at the time. And the pod doesn't have enough CPU, or the nodes don't have enough CPU. So it's showing this error until it actually scales appropriately. So you see now we have 5 nodes. This probably just became ready. And we'll probably shortly see, there we go. We've already seen that error disappear. So that's the beauty of having the Kubernetes cluster node groups auto scaling, as well as the horizontal auto scaler. Now, if we go back to our job, we see that it's finished. It's gone through 854 tasks. And during that time, it scaled all this stuff up. Now, I'm not going to wait for it to scale down. It will. It takes a few minutes. We'll start to see some of these disappear. And usually what you end up seeing is this running over here turns into error, because that's what a termination starts to look like. And then it'll say terminating, and then it'll go away. But this is, I like this because even just with the collection on S3, if I have a ton of data I'm going through, and we do this in our corporate log stream all the time, if I have a ton of data that I'm pulling in, it will scale up to pull that data in rapidly, and then it'll scale down to go away. And that's completely configurable. So I can say I only want to scale to 4. I can set my thresholds higher so that I get the type of auto scaling I'm looking for, but nonetheless, it's available there. So with that, that is the demo. Now we have a fully working distributed environment with one worker group, with a little bit of config that we preheated it with, and that's it. That's Kubernetes deployment in a nutshell. So I'm going to stop the share and open it up for questions.
Very
Anyone?
comprehensive, Steve. Thank you.
Sure.
Okay, yeah. And if you don't have questions about this particular thing, it is also totally appropriate to ask questions about any other aspect of Logstream, etc.
We've got a slew of Logstream knowledgeable folks on this call. So
Yeah, you're pretty much outnumbered. So, but yeah, I'm curious to know how many people actually watch these recordings afterwards. I don't know if there's a way for Zoom to tell us that or not. But not everyone can make it at this particular time, I'm sure.
I think I can go back into the Zoom console and get some stats on it. I'll look.
Okay, yeah, we got them. I think we've got the links to them pinned in the SE in the office hours channel. So, and I'll be pasting this one out, or I don't know.
So, question for you, Steve. Hopefully my mic is good. The speed of restarting, if you will, how fast can you control that? Make them come up faster, or what's throttling that?
So the only thing that's throttling it is going to be resources in the Kubernetes cluster. On the worker group, if you don't have persistent storage set up for anything, then that's really going to be the only gate is, do I have resources to spin this up? The worker groups actually spin up really quick. I've actually seen it where I'll type the Helm install command and within about 10 seconds, it's already connected. That obviously depends on whether whether the container's already in the cache on the Kubernetes environment or not, but needs to download it, et cetera. That's actually one of the bigger gates for spin up time for a lot of these things, is if it has to go get a new version of the container or not. On the master side, one of the biggest gates is the mounting of the persistent storage. So often, and we'll see this in, we'll have a node die in our production environment. EBS doesn't release that volume right away. So when the new node spins up and the workload gets scheduled, it will immediately say, I can't mount this because somebody else has got it. So it usually it can take up to 5 minutes for that to be released. I've noticed variances in there, right? Sometimes it's almost immediate. Sometimes it takes up to 5 minutes. There's nothing really we can do to fix that. It's kind of dependent on the Kubernetes implementation and how it's dealing with resources. But that's kind of it. There's really nothing gating, other than resource management. There's nothing gating that spin up time within the chart itself. Does that make sense?
Yeah, thank you.
Sure.
Great. Awesome work, by the way.
Yeah, I'm super excited about this new version. And Katz, you and I are going to have to go through a lot of documentation. I'm starting to write all the stuff for it now. But there's some pretty significant new things in here that we'll have to kind of point to. But when I started working on this stuff, I thought, okay, cool, we're going to add all this capability. And then I started preparing for this demo and realized, oh my God, all this capability is what's enabling this to be much easier. So I'm actually really, really excited about it. Any other questions?
And I take it this will be released or
Yeah. So I'll be releasing a new version. I try and keep close to our Logstream release, but it sometimes takes me a little longer. So I'm expecting I'll be able to release sometime early next week at this point.
Awesome. Thank you very much, Steve.
No problem.
All right. I think we probably don't have any more questions. Anyone? So see you in 2 weeks. And what's the topics next time, Tim?
I actually forget. Let me look super quick. We have so many lined up for the next couple of weeks.
I think it was Brandon.
Oh, Brendan's going to walk us through a custom script to pull data from Okta through pagination.
Awesome.
Pretty cool.
Yeah, we'll try to make sure that the Zoom link is open to everyone this time. I don't know whether you changed it going forward. Yeah, I don't know if it's the same each time or what, but cool. All right, and yeah, you should get the recording info. I'm not sure if I will still get it because I'm not the co-host of this meeting.
I'm sure I'll get it. I'll pass
Make
it
sure
on.
to post it. Great, thank you.
Thanks,
Awesome.
everyone. Have a great day. Thanks, Steve.
Bye.